Hello, I'm Trueba, Chief Technical Officer of FIRSR Robotics Competition Team Member 4301, the New Tech Narcissists. And here to my left is Team 4301's entry in the 2016 FIRSR Robotics Competition and its associated tournament challenge, First Stronghold. This robot was designed with a key focus on the concept of elegant simplicity. Team 4301 has come to the realization that more moving parts does not necessarily equate to a more effective robot, and has decided to approach this year's game by having the robot do as much of the challenge as possible using as few articulated components in order to reduce the chance of failure and therefore create a more robust machine. On the front you have a single motor controlling a wheeled intake that serves a dual function of both intaking balls and storing them inside the robot to traverse the field, in addition to being able to spit them back out into the low goal to score points against the tower. On the rear of the robot we have our multifunctional wheeled manipulator arm, which was designed extensively in CAD programs in order to create a single arm that is capable of manipulating not only all of the articulated defenses such as the portcullis, the cheval de frise, the drawbridge, and the sally port, but is also capable of lifting the rear end of the robot off the ground by a couple of inches in order to facilitate traversing the fixed defenses that are more terrain-based. By making use of this simple, multifunctional design, the robot is capable of traversing most, if not all, of the defenses that would be present on the field in a given match. So let's take a closer look at the design aspects of this robot. At the core of the robot is an AM1FOR-U3 chassis assembled in the square configuration, but modified such that the front and rear frame members were not shortened, resulting in a frame with a perimeter of 119.5 inches. This enabled the robot to have a larger gap in the frame in order to intake boulders with. Because one of the team's objectives in this game was to be able to pass under the low bar, given that it is the only defense that is guaranteed to be on the field at any given time, the robot needed to be built to be compact. In order to facilitate this, the electronics package needed to be condensed considerably. Inside our robot, we have a two-layered electronics package which consists of all the necessary control components, all housed within the rear half of the robot on two separate panels. This enabled the robot to be much smaller than it could have been otherwise given a single layered panel. And in addition to this, it gave a lot more room for the ball intake section of the robot. The team opted to go with the 6-inch wheel tank drive configuration after creating several CAD models and coming to the conclusion that the robot's overall performance, thanks to the manipulator arm, would not be hindered by the small wheels and the low ground clearance. Of course, a robot wouldn't be a robot without a good level of autonomy built in. The robot utilizes a series of limit switches on the leading edge of the intake ramp, which enables the robot to stop the intake rollers within 0.1 seconds of successfully collecting a ball. This enables the robot to be operated without so much human intervention. The robot also possesses several sensor-assisted autonomous modes, which enable the robot to pass through either the low bar, the cheval de frise, or the portcullis at the beginning of any match, and it enables the robot to do so while going in a straight line without interfering with other machines thanks to built-in gyroscope support. Of course, teamwork is key to getting a robot like this successfully developed and put together. The New Tech Narcissists come out of New Tech Odessa High School, which has about 300 students at any given time. So our pool of potential robotics team members is significantly smaller than you would find on many other teams. Our team consists of about 15 total members. In order to do this, we need to make sure that everybody is well trained and efficient at their jobs prior to the start of build season so that we can get the robot done on time before bag and tag day. In order to do this, we have a large set of team building sessions prior to the beginning of the build season. Team building and training begins at the beginning of the school year and continues through the beginning of build season. During build season, we are actually working on building our robot at that point, and everybody should already know what they're doing. But team building continues through the build season in the form of building the robot. So the team not only is capable of building the robot effectively, but also capable of having fun while doing it, which honestly is really the point of the FIRSR Robotics Competition, because FIRST's mission is to inspire students, and it's not really that inspiring to have a group of people that are just constantly stressed and not having fun while doing so.